All right. So we're going to do some practice with Newton's second law. Force is equal to the mass times the acceleration. So it's a simple formula. Mass, when they're side by side, times acceleration. All right, forces equal into newtons. We use the letter N. All right, so we'll be reviewing the first law. Need to know that. Give me the test. And then we're going to practice some calculations. The relationship between force, mass, and acceleration, and use the second law to calculate the mass and the acceleration. Okay, so motion is in our lives, and the second law explains the relationship between mass, force, and acceleration. Understanding the second law lets you correct the amount of force needed to understand how mass might affect the motion. We're going to use Nearpod, Big Blue Button, and a chat, some polling, and to analyze how motion is related to force, mass, and acceleration. Okay. Bit sluggish. There we go. All right. So according to Newton's first law of motion, so we're doing that review, motion of an object does not change as long as the net force is zero. So an object at rest remains at rest, and a moving object continues moving at a constant velocity. It's also called the law of inertia. So Newton's law, you can take a look at this. So it takes the greater the mass, 300 kilograms, shows that's a large mass, kg, about 2.2 pounds, so about 600 pounds, takes more force in newtons to move than, or change the motion, than a 30 kilogram, so about 60 pounds. So an object will not change its motion unless acted on by an unbalanced force. So we'll be talking about unbalanced forces. If it rests, it stays at rest. If at motion, it remains at the same velocity. No acceleration, so it's not speeding up. Okay, so we're going to do this assignment here together. I'm going to do this. Okay, so here we want to look at these forces. These are forces from the right, going to the right, and forces to the left. And we're going to change this by moving this red. So because this is an unbalanced force, 4 going to the right, 3 cancels 4, and we're going to get 1 Newton to the left, right? So these forces are the same in opposite directions. So this is going to be a 0 net force. And here, both of these forces are moving to the right. So that becomes a force of 8 newtons. So it's like 4 newtons pushing, 4 newtons pulling. Okay, so let's do some challenge me questions. What can be inferred about the magnitude and direction of an individual forces acting on an object if the forces are at rest? Net force is 0. So notice the arrows are pointing in opposite directions, and they're the same size. So which one of those says opposite directions? But this one says different magnitudes. They must have the same magnitudes and opposite directions. Needed a cough drop there, sorry. All right, so which of the following correctly orders the net force in system from least to greatest? So the blue is the least, the green, then the purple. Blue, green, and purple. There we go. All right, next one. Suppose the magnitude of each force on the boxes were doubled. Which box would have the least net force acting on it? So if we double this, 3 and 4, we'll get, this will make this go to 2 newtons to the left. Here we go, 10 and 10. Now those are balanced, so this will still be 0. Here is 4 and 4 going to the right. That will make that 16 if we double it. So we're going to say blue. All right. So Newton's second law states that the acceleration of an object is proportional to the net force applied on the object, inversely proportional to the mass. So the more force we put on an object, the more acceleration we'll get. But the smaller the mass, the more acceleration, more we can accelerate it. So that's why it's inversely proportional. So if we make the mass smaller with the same force, acceleration goes up. So inversely, one is going down and the other one's going up. All right. So if all the objects on the right have the same mass, which object would experience the greatest acceleration? This would be the purple one. All right. So we're going to move on from there. And let's do this next one here. Okay, those are some quiz questions for you. All right, so let me do some examples. Force is a vector, force in newtons. Mass is a scalar, and acceleration is a vector. So mass times, and then because they're next to each other, we use this triangle. Force, mass times acceleration gives you force. So if you cover that up, that'll give you force. And so we're going to do some practice using this triangle method here. All right, so let's do this. Okay, so let's do purple. So, okay, we're going to cover up the force. What is the force needed to push a 4 kilometers per meter per second? So that means it's acceleration. So we want to cover this up. There's my nail. So mass times acceleration. So 4,000 kilograms, it doesn't matter which I do first, times 4 meters per second squared. So this is 16,000 newtons for kilogram kg dot meters per second squared. Same thing, they just use the letter N. All right, determine the acceleration now. Okay, so we're going to do that. So we're going to do the acceleration of this one. So again, we're going to cover this up with our finger. Force divided by mass. So 100 newtons, which is the same as kilogram times meter per second squared, divided by 50 kilograms. So the kilograms cancel each other out. This is 2 meters per second squared. All right. An object, find the mass. Okay, so this is the mass question. So force divided by acceleration. So we got 40 newtons, which is a kg dot meters per second squared. Same thing as newtons. And we're going to divide by acceleration. 8 meters per second squared. Cancel these out. This gives me 5 kilograms. And that's our mass. All right, so from here, ladies and gentlemen, you will be doing these on your own. So you will be doing 1, 2, 3, 4 slides, and you can submit those. All right, thanks so much.